So I'm here to speak about BitcoinJS today, and it's a JavaScript library. And I wonder, are there any JavaScript developers here or that have used BitcoinJS lib? They have complained to BitcoinJS lib, but they haven't listened to your issues for about 10 months. And so I want to give you a bit of background on BitcoinJS, and for those of you that are not familiar with the JavaScript implementation. So BitcoinJS is the only JavaScript implementation of the Bitcoin protocol on the web. It's used by blockchain info, BitPay, BitGo, Bread Wallet, and pretty much anyone that needs any kind of JavaScript support for Bitcoin. It's the only support that there is. And a little bit more about the timeline. So Stefan Thomas, who's the co-founder and CEO of Ripple, started working on BitcoinJS in late 2011, and then he founded Ripple, and then he stopped working on BitcoinJS in late 2012. And since then, there's been a couple of maintainers, and the maintenance has been on and off. And the last hiatus on BitcoinJS was over 10 months, where they just didn't listen to any issues or respond to any pull requests. And so, as a result, every company that uses any kind of JavaScript has now a fork of BitcoinJS, or blockchain info has one, BitPay has one, which is Bitcoin, and Eric's going to speak about Bitcoin next week. And then there's BitGo, and everyone has the same. Everyone's forked it, and also because they have bugs in the original implementations, there's some small bugs here and there. Protocol has changed since then, and so that everyone has fixed the similar bugs. And as a result, every implementation is incompatible with each other. So we decided, it was me and a guy called Jake Richardson, and there's another guy called Brooks, to create another fork of BitcoinJS. But the difference is that instead of being a fork that's maintained by a company, and pretty much means that if you build an app using, for example, Bitcoin, you're logged into whatever BitPay wants to do with Bitcoin. And then we thought, well, that's not right. You can't have your app, which is the JavaScript implementation of Bitcoin is the most critical dependency in any Bitcoin app. And you can't have that tied to another company that is, well, probably a competitor. And they can change the API however they want based on their business needs. And so we thought, okay, well, why don't we have a community fork? And that's browser and server-side compatible for Node.js and JavaScript browser. And so, BitcoinJS, there are a couple of things I want to speak to you about, which is the implementation of BitcoinJS, its design, the test coverage, and community-driven nature. And these are some of the, I would say, some of the kind of the more important aspects of why this as a community fork is better than the other implementation, the other forks, and that as a developer, this is probably more suitable. And I'm here today really, to talk about this, and also then to see if other contributors will come on board and start maintaining the community repo. And so the first aspect of this is that the library is actually pretty kick-ass. It has full implementation of pretty much everything you need, and we brought it from various places. All of the dependencies within this set of libraries and these ecosystems are all within BitcoinJS, which is a set of about 20-30 repositories and modules. And just to give you some ideas, in terms of the Bitcoin protocol, it covers pretty much everything. So it addresses, covers scripts. It has a script interpreter, which means that if you build Bitcoin scripts, then you can run through interpreter, and you can basically see every step of the execution. What's been pushed onto the stack, what operation has been done onto data on the stack, and then basically then what happened in the next step. It covers transactions, and then there's a bunch of more generic libraries, scriptal, binary, and encoding, like basic things like passing binary strings, doing conversions, all kinds of hashing algorithms, base 64 and 58 encoding, and obviously elliptic curve topography, and a range of other modules. And then it also has a wire protocol implementation that we're still working on, And what that means is that it gives you a full node implementation on the Node.js side. And so basically it allows you to have peer-to-peer communications with the Bitcoin network. You will be able to connect to any Bitcoin node and start communicating messages with them. And it also, well, it's not implemented yet, but also we also have a level DB backend which then would index all the transactions and it will operate like a full node, like BitcoinD, but it's Node.js, which means that you can hack on it. You can do, basically do whatever you want. For example, if you want to listen for particular addresses and have triggers for that, then you'll be able to do that with the full node implementation and set triggers to say, all right, pass every transaction that's happened to the network, and then if I see a particular address that I'm interested in, then kick off a webhook or kick off some other triggers. And I think that's particularly important if you're building some kind of server-side Bitcoin app. And there's a whole lot more. There's Bit3a, there's HD Wallet, there's key derivation functions. And it's also compatible with altcoins, and I'll explain why that's the case in a second. And so, to give you an example of what this looks like, I don't have time to go into the individual modules, and we might have time later. Anything in this ecosystem that's prefixed with BTC is Bitcoin specific. And anything that doesn't have a BTC prefix is basically general. So for example, BS58 is basic PA encoding, Big-E is big integer, BitString is basically conversion between binary strings into byte arrays or buffers in Node.js, and eCurve and all that. So the implications, I think the implications are important, which is that anyone here, if you're looking to build an app that has a browser-side component or in Node.js, you can pick any of these components out, and that would be a drop-in module into your app. So for example, if you want to build something on Litecoin uses the same kind of set of modules than Bitcoin would, for example. And in the case of an address, the difference really is the version byte that's in front, and everything else, as far as I know, is fairly similar. And you can use the same modules that we use to implement Bitcoin to do Litecoin support. And I think that's kind of the value proposition of a community fork. And so the next aspect of this is that Bitcoin protocol is pretty overwhelming, and I really want to know, and I'm just curious, how many people here have actually hacked into BitcoinD, the source code of BitcoinD? Of course, of course he has.
It's a mess.
It's a huge mess. Okay, so one person is hacked into BitcoinD. Who else has looked into the source code of BitcoinJ? It's also a very big thing. What about Bitcoin Ruby? And Bitcoin Ruby is also a very big, I probably shouldn't say this on camera, but it's a big mess. And it's very hard. Like, if you want to take it out, it's like, I just want to make this app do one thing. You can't really do that. I mean, it's all like, integrated together in like a very tight, neat kind of way, and you really can't make it do things that you want. As a developer, that really sucks, I think. And so the design of BitcoinJS is to break everything up into individual components and small modules. Basically follow the Unix philosophy, which is we'll try to make everything as small as possible and make it do one thing and one thing well. And so that means if you're a developer that's new to Bitcoin, and you want to start supporting Bitcoin, or learn about Bitcoin, you want to hack on it. If you hack into the source code BitcoinD, you're probably not going to learn Bitcoin. but whereas here is a good starting point. And I want to give you an example of how easy it is. So if you and I assume some of you might be new to Bitcoin development, and the first thing that you probably do is look at what's a Bitcoin address and how that works. And so if we take a look at BTC address, which with Bitcoin prefix, which BTC prefix, which is Bitcoin specific, you can see that, well, Bitcoin addresses are very simple. It's all it is there's a version byte in front, there's the hash 160, which is 20 bytes, and then you append a checksum in the end, and then you encode it basically. So there's only a couple of steps. And so if you want to start hacking on Bitcoin apps and you want a starting point and you want to start maintaining some modules, you can start from BTC address, which is about 100 lines. And that's kind of, I think for someone that's new to Bitcoin development, it's kind of digestible. You can kind of look at it and go, alright, it makes sense. And I'm not going to show you the source code of Bitcoin. Actually, I'm going to show you the source code of Bitcoin. Some of the files in Bitcoin Ruby are just big, can't really understand it, and if you want to use it as a dependency, it really will become a black box, which is, according to documentation, this should happen. Most of the time it does, but some of the time it doesn't, and you don't really know why. And it's really hard to work with that. And I think that's kind of one of the things as when we develop this set of libraries that we wanted to do, which is make it easy for people to develop with. And now we're also starting to develop a set of modules which is generic to all different kinds of coins. So an example of that is coin string, which is basically, so as I talked about before, and BTC address really is version byte, 20 bytes of hash, and then a checksum in the end, and that's actually universal across a lot of different coins. And the only difference really is the version byte. And so why don't we have a library that just accepts a version byte as an argument and supports all kinds of coins? And if you want to develop an address module for Litecoin, for example, you can just drop that in, and then that becomes your backend. So that's kind of another thing that's considered. And so lastly, is test coverage. So the original implementation had good test coverage in it, and then every other fork since then has no test coverage, including some of the more prominent implementations would have basically the only test in there would be something should exist inside. Oh, there's one test for this module, and it tests that the module exists in this repository. And I'm not actually kidding, I can show you later. And that's not really a test, that just kind of shows that there's a file there. And so another thing that we've been thinking about, and obviously looking for contributors to come on board, is to create BTC fixtures, which is in the BitcoinJS source code, there's a whole library, a whole folder of fixtures. Of all kind of edge cases. So for example, if a script is longer than 10,000 bytes, that's an invalid script, and that's an edge case. If a script does this, that's not a valid script, that's blah, blah, blah. And so we're going to create a whole set of reports, put all the fixtures in there, and then that fixtures report can be shared amongst all the other modules, and basically share fixtures and have a very good test coverage. And at least the same level of test coverage that you would expect from BitcoinJS, for example, because it would take all their fixtures.
How far are you guys from implementing the fixtures?
Only to some small degrees, but that's been planned for the next maybe 2-3 weeks. So this whole set of libraries hasn't gone to a stable release yet, but we're really hoping to get to a stable release and bring more developers on board and maintain this for the long run. And lastly, I think the more important thing, and why I'm here today, and some of you might be interested, especially if you're a JavaScript developer looking to develop Bitcoin applications, is the fact that this is community-driven and community-maintained. If you go with an implementation that's maintained by a company, you're really locking yourself in to that company and kind of whatever they want to do with the most critical dependency you have in your entire application. And personally, for me, that's certainly not acceptable. As this big black box dependency that's maintained by someone that has a vested interest to not see any other app do well. And so ideally then, we hope to bring more commuters on board, extend push access, so that if any of the commuters drop off and take a holiday, this library just will live on. And hopefully no more 10 months long holidays for BitcoinJS, just like what happened in BitcoinJS, where no one maintained it and every company had to focus on fork. That's kind of all I have today about this kind of ecosystem. And I want to end it today with a little cool project idea that I've been thinking and can be implemented with the library, and see if someone wants to hack on it with me. So has anyone used like JS Fiddle or like CSS Fiddle, SQL Fiddle? It's nice because you can kind of put some small chunks of code in it and you can kind of see it run. I think one thing that's kind of overwhelming about Bitcoin is that like how scripts run. It's kind of a mystery. Kind of this idea that, oh, you have things that get pushed onto the stack and the operations run on it, but I don't know if it's going to work. It's kind of like how to visualize, how to imagine how a script actually get interpreted and how operations actually get performed. And so in BitcoinJS there's a module called script interpreter, which is basically a small interpreter that interprets all Bitcoin scripts and it basically pushes your script seek and the pub key onto the stack and then runs script pub key on top of it. And so the idea that I had was to build a Bitcoin script fiddle, which basically, because Bitcoin has a set number of operation codes, we can listen operation codes, and then you can drag and drop the operation codes into PubKey, and then you can drag whatever combination you want, and then you can run the script and see each single step of the operation. And the library can already support that. You can see how the operation will run. OP juke, what does that do? It copies the top stack, and then OP SHA-256, what does it do? It does a hashing algorithm and returns this thing. You can see each step of execution. So everyone can play with their own scripts and kind of create a custom script and then propagate onto testnet and kind of see it run in real life. And so that's an example of some of the projects that you can do when the modules are separated out from this big hairy mess that is, sometimes we see that in Bitcoin Ruby or some of the other libraries that's more kind of intertwined and you can't really do much work. And so that's basically it about this ecosystem. And I think a lot of you might want to see some code. And so I'll probably open this up to the floor and see what people want to know about.
How far are you with Bitcoin script?
The script interpreter. So the script interpreter is done. So now we do the front end so that we can drag and drop stuff. There's a module called BTC opcode, which lists all the operation codes in Bitcoin. And the script interpreter then knows how to operate on those operation codes. So I can give you an example. Let's show some code. So the script interpreter basically looks like this. It loops through the operation codes and chunks on the stack, and then it basically then checks, what kind of operation it is. So as an example, is anyone familiar with like script pubkey, like the common pay to script hash? Sorry, not pay to script hash, pay to pubkey hash script, which is opjuke, op hash 160 stack. And this module will help you understand how that works, and if we could visualize it, that would really help. So we'll start from opjuke, which then takes the
Can you zoom in a tiny bit?
Sorry?
Can you zoom in?
Right.
Thank you.
Bigger? Right. So a typical, the most common script, which is op hash 160. Sorry, opjuke, op hash 160, 20 bytes, and then equal verify, and then check seek. And through this module, you can actually see how each operation gets performed. And as an example, the first operation is typically opjuke, which is copy the top stack and then push it back onto the stack. And you can kind of see it here. So that's an example of what you can do with the script interpreter with one of the modules here.
What's your version of the scheme? Do you match the reference plan? Or is it?
Try to match the reference plan, and basically, whatever the reference plan will do, then this will follow.
Okay. How far do you like behind it?
Sorry?
How far do you like behind reference?
Well, as far as I know, we have everything up to the latest. And in terms of like the bips, so we currently have BIP 38. We have, I think, HD wallet. I'm not 100% sure because I don't work on that because it's a different module. And in terms of the upcoming release at 0.9, we haven't done OP return yet. Like, so you can't create a OP return output, but that's going to be added soon. We haven't done anything with BIP 70, but I think one of the guys wants to work on it.
How are the docs?
The docs are lacking. But will be better when it goes stable. But the modules are pretty small, so when you look at the module, for example, the address module, you can typically see who comments what's doing, but the docs are pretty lacking. And that's something that needs more work on.
Do you know anybody using altcoins that use BitcoinJS?
We've heard of it. We've heard about people talk about using this, but no one has kind of come to the repo and say, hey, can I have a Litecoin address module in here? That hasn't happened yet, but you know, if anyone wants to do that, it would be pretty awesome.
Because all the altcoins use ECPSA in the same way, you can actually have a single private key that has public addresses for Bitcoin, Litecoin, Dogecoin, whatever.
Yeah.
So you can have a single wallet that holds any type of currency. Essentially, you can do not just 2D wallets like hierarchical deterministic, but you can do 3D wallets where you have a tree of private keys that then has layers of public keys for each altcoin above it. And you can have essentially a multi-currency wallet, and nobody's done it because everybody looks at each coin separately.
That's a good idea. That's a good idea. That's a good idea.
What's the timeline for stable release?
Soon.
Soonish.
maybe another couple of weeks.
Do you think this is capable of being a full Bitcoin client like P2P, not just the SPV client? Because BitcoinJS, if I remember, was just SPV client only for a long time. Is that something that...
So it actually does P2P. There's BitcoinJS lib, and then there's BitcoinJS server, which had the P2P, and we actually took that as well and broke into 3 modules. There's the Bitcoin P2P, there's the P2P, which is a module that manages single connection. So if you want to build an app that just listens to your own Bitcoin D, for example, and you just want to listen to it and put triggers on it, then you can use that module and just listen to one connection. There's the P2P manager, which manages multiple connections, and then there's this BTC P2P, which then is the full implementation, and it manages a connection pool, it manages a memory pool, and then backs into level BB. But that part hasn't been worked on yet. So that's still being worked on. But the connection parts are all done. And it speaks the protocol. So it knows how to connect to peers, doesn't know how to talk to peers, but it knows how to listen.
It's cool.
The difficulty in building a full node client in any language is that you have to simulate every single bug in Bitcoin D. Otherwise, if Bitcoin D does something in a buggy way and you do it the right way, you're on the wrong fork.
Do these fixtures that you were just talking about cover all these bugs?
The fixtures.
The fixtures, do they cover all these known
No.
bugs?
No.
It's very difficult to cover all the bugs. That's why you don't see too many full nodes. It takes an enormous amount of development and maintenance.
I guess it would help to have them all in those fixtures you mentioned, right? If that's
Yes,
impossible.
it's not just edge cases, it's also backwards compatible historical stuff. So like before block X, it behaves one way, after block X, it behaves another way, and there's lots of those as well, which are really in the Bitcoin D code. At the moment, it's very tightly covered. And the problem is because everybody's running Bitcoin B, if your full node does something even slightly differently,
Yeah.
like for example transaction malleability handling, you end up on the wrong side of the trust.
Yeah.
So that's the main reason why you don't see a full ecosystem of these.
And certainly, I think it would be wise to run this at like a full verification mode, and kind of because you risk a hard fork from the main chain. But if all you want is kind of listen to addresses, have triggers, maintain some kind of mempool so that you have the mempool and things of that nature, or propagate non-standard transactions to particular miners, for example, I think that would be it would be relevant. But listen to the man.
Essentially, there's a difference between being a relay network node, which you can do fairly easily, and being a relay network node with a full blockchain and doing full depth verification. That last part is tricky, especially if you want to actually decide whether you're going to spend money based on what you're seeing on the blockchain.
So verification. So we're just talking about that. So
it doesn't do full verification. It basically listens and it tells you what it heard, and you make a decision to what you want to do with it. And so you're like, I wouldn't recommend you run a full node with it and then kind of spend money based on what this tells you. But it's more for if you want particular functionality and listen to events and have webhooks and triggers and that could be relevant.